Today's lecture regarding the thermal sensation. Today we are going to learn about the pathways which are related to temperature as well as to pain. As we are actually doing the sensory nervous system, as we all have already done the dorsal column, medial lemniscal system and stuff. So today what we are going to conclude the sensory system is with that of the temperature and pain. So let's talk about what are thermal sensations. So as we all know that human beings can perceive various grades of thermal sensations. So we have the two type of thermal receptors, which are cold receptors and the warm receptors, pain receptors. Now at extremes of temperature, the pain receptors are also stimulated when there is burning hot or freezing cold there. So as I already have told you before that whenever there is any extreme of the sensation which is not tolerate or tolerable to our skin or body, what is perceived is that of pain. The cold and warmth receptors, they are there and they are immediately located behind or inside or under the skin at discrete separate points, spots. And these spots or points you already have done regarding the classification of receptors. You have done Meissner's corpuscles, Ruffini's endings, Merkel discs. You have done so many. There are free nerve endings, so there are 3 or 10 as many cold spots as that of the warm spots. The number is quite different in different body areas, like we have 15 to 25 cold spots per square centimeter in lips, and like we have 3 to 5 cold spots over there in the finger. We have quite less over there in the broad surface areas of our body, which are like on the back, trunk. We have like one cold spot. So you can see that the areas where the precision is actually required, we have quite high the number of the cold spots, like 15 to 25 per square centimeter over there in the lips, and like 3 to 5 over there in the finger, and where the precision or accuracy is not very much important, which is the area of our trunk or our back. Over there we have the spots like only one. Now look at this histological diagram of the skin. You can see that the layers of the skin, we have on the topmost we have epidermis, then there is dermis, then there is hypodermis. Now look at different sensations. We have different sensations like cold, hot, we have pain, we have pressure, sense of position, touch, vibration. Now all the sensations we already know that they are to be carried out. They are to be carried upwards along the spinal tract towards the main boss, which is that of the CNS, by way of the upward system of the dorsal column medial lemniscal system, with exception of only that of temperature and pain, which are to be carried upwards by that of the anterolateral column. You can see that different receptors, which we already have done quite in detail in the classification. You can see the picture of Pacinian corpuscle here, the nociceptor here, the Meissner corpuscle, the thermoreceptor. Now look at this diagram again. You can see that the epidermis is actually showing the different 5 layers of the skin, and in dermis you can see the receptors which are there for the light touch, for vibration, for pain, cold, warmth, etc. Now the free nerve endings which are present in dermis, they are actually meant for sensations like pain to be carried out. Like for warmth receptor impulses, they are being carried by the C fibers at the rate of, or you can say by the speed of around 0.5 to 2 meter per second. For cold receptor impulses, we have different type of nerve fibers. We have A delta fibers, we have C fibers, which are having the speed which is quite high in comparison to that of the warmth receptors, and that is around 20 meters per second. Now we are going to talk about the stimulation of thermal receptors, sensations of cold, cool, indifferent, warm and hot. These are actually the different gradations of different temperature ranges which are actually to be felt by us. Uh, pain fiber stimulated by cold, a cold fiber itself, a warmth fiber, a pain fiber stimulated by heat. Note specially that these fibers respond differently at different levels of temperature. As I already have told you that if the cold that is not bearable, that is actually going to give the sensation of pain. If there is heat which is not tolerable, that is going to give you the feeling of pain again. So this is actually the responses, whatever the gradations we are actually feeling. They are actually the sum of all these four type of nerve fibers. In the very cold region, only the cold pain fibers are stimulated. Like if body nearly freezes or actually freezes, these fibers cannot be stimulated. Now as the temperature, and there is actually the gradation at which some of the fibers they're going to become active, and later on they are actually having the ranges at which they actually become active. Like if the temperature rises from plus 10 to 15 degrees centigrade, the cold pain impulses actually stop. The cold receptors they begin to be stimulated, reaching the peak at about 24 degrees centigrade, and then they start to fade out at 40 degrees centigrade. Above 30, what happens is that the warmth receptors they become to stimulate and they become to fade out at 49 degrees centigrade. Finally, at around 45, the heat pain fibers they begin to be stimulated by heat. Paradoxically, some of the cold fibers they begin to be stimulated again, possibly because of damage to the cold endings caused by excessive heat. So this excessive heat is going to damage some of the cold fibers at the same time. So that's why they are going to be acting oppositely, that the cold fibers themselves they're going to give the feeling of pain at this time. You can see by this graph which is actually showing us the gradation, that how the different receptors they are being stimulated and what is their relationship with the temperature range, and what is vertically you can see that how much impulses per second they are actually given. You can see that the cold pain receptors they are at the freezing cold temperature they are actually activated, and they actually stop or cease to respond at 15 degrees centigrade. Then around 7 degrees centigrade, you can see that the cold receptors, they start to send impulses, they start to respond actually. And right between 42 degrees centigrade, they actually stop to respond. At the same time, at 30 degrees centigrade, the warmth receptors, they actually start to respond, and thus response actually stop at 50 degrees centigrade, and at 45 to 50 degrees centigrade all the nerve fibers they actually start to be get damaged because of the intensive heat which is being given to them. So they all start to give us the feeling of burning hot, and a sort of vicious cycle actually start at this point. A person determines the different gradation of thermal sensations by the relative degree of stimulation of the different types of endings. When intense enough, may give almost the same quality of sensation, that is, freezing cold and burning hot sensations feel almost alike. Now we should be knowing, when we are learning about the thermal receptors, we should be knowing about their properties. Now, we should be knowing that if we talk about the number of receptors, we should be knowing about the sensitivity as well. Well, see that the mucous membrane of the mouth is relatively quite insensitive to hot fluids, which are almost quite not tolerable on our skin. So that's why one can drink hot fluid which cannot be tolerated on the skin. The exposed areas, they are relatively less sensitive to temperature changes as compared to the covered areas of the body. Like you can see that even in severe winters or severe hot weather, we are not going to cover our face or scalp or hand. We are not feeling as cold or as hot on these areas in comparison to the areas which we usually cover. In exposed areas, the temperature change can be detected within like zero point 0.5 to 1 degree centigrade, while the covered areas, they can detect the change of zero point 0.2 degrees even. The thermal sense is more marked in chest, nose, anterior surface, or upper arm, forearm, and abdomen. So we have the neutral zone as well, and that is actually between 29 to 36 degrees centigrade. So dear students, this neutral zone is very important because it is frequently asked that what is actually the neutral zone of temperature, and the answer is actually that is 29 to 36 degrees centigrade, and at this temperature we don't feel any warm or cold. Why? Because both the receptors, they are equally stimulated. Now when the temperature is below 29 or above 36, we feel warmth or cold. And humidity factor is very important. If humid, even 36 degrees is uncomfortable. In dry weather, even 45, that is tolerable. So we should be knowing about the variety of sensitivity level, there is variety of number, there is humidity factor, there is neutral zone. These are quite important things. Now if we take two materials, let's talk about wood and metal. With same temperature, metal is felt cooler because it is actually a good conductor of heat. Thermal receptors respond to static temperature but much more to changing temperature. If the temperature is falling, we feel more cold as compared to fixed cold temperature during snowfall. When there are thermal changes, these affect metabolic rate in receptors, so accordingly receptors are stimulated.